Here is the answer key for the u substitution assignment. Question 1, using the substitution u is 2x plus 1, rewrite this integral. Okay, step 1, u is equal to 2x plus 1. Step 2, find du. Du is equal to 2 dx, the derivative of 2x plus 1. We have the 2, we have the dx, so we can make the perfect substitution. We have u being cubed, du. Last step, change the bounds. 0 plugged in, so we have twice 0 plus 1. New low bound is 1. 2 plugged in for x gives us twice 2 plus 1. New upper bound is 5. And we're done. Next up, using the u substitution 2x squared, rewrite this integral. Okay, u is equal to 2x squared. Du is equal to the derivative of that, which is 4x dx. We have the x in the dx. We don't have the 4, so we can put it in. 1/4 counterbalances on the outside. So we have 1/4, the integral, cosine u du. We need our bounds, so we plug 1 and 3 in for x. Twice 1 squared is 2. Twice 3 squared is 18. 3 squared is 9. Doubled is 18. There's our rewrite. Alright, switching to the second section. Same thing, just rewriting in terms of u. So for number 3, u is 3x minus 4. Du is equal to 3 dx. We have the 3 in the dx, so we have the antiderivative, the integral from u to the 4th du. Our new bounds, well, 3 times negative 1 minus 4. That's negative 3 minus 4 is negative 7. 3 times 2 minus 4, 6 minus 4 is 2. And we're done. We now have number 4, the integral from 0 to 2 of x over 2x squared plus 3. We're going to make u equal to 2x squared plus 3, setting up a u du situation, or a du over u situation. Derivative of 2x squared plus 3 is 4x dx. We are missing the 4, so 4 on the inside, 1/4 on the outside. So we have 1/4, the integral. Du is our numerator, u is in our denominator, and we're going to plug 0 and 2 in for x. So when we plug in 0, you can see that we get 3. When we plug in 2, 2 squared is 4, doubled is 8, plus 3 more is 11. And we're done. With number 5, and move up a little bit. Alright, u will be the inner function of sine, so we have 2x squared minus 3x. Du will be 4x minus 3 dx. What a coincidence, we have the 4x minus 3 and the dx. No changes need to be made as regards to du, so we're going to have sine of u du. We plug in our bounds. We plug in negative 1. We have twice negative 1 squared minus 3 times negative 1. So we have 2 plus 3, which is equal to 5. That's our u equals 5 is the new low bound. And now we plug in 1. So we have 2 times 1 squared minus 3 times 1. So we have 2 minus 3, which is negative 1. Those bounds are backwards. So we'll write this one more time as the opposite of the integral from negative 1 to 5 of sine u du. And that'll be our answer. Finally, number 6, u is equal to x squared. Du is equal to 2x dx. We don't have the 2, so we put it in. 1/2 on the outside, so 1/2 in the integral. Secant squared was never touched. X squared is the same as u, so we have secant squared of u. 2x dx, same as du. Now we need our bounds. 0 squared is 0. The square root of pi over 2 squared is just pi over 2. We're done.